Hello guys, how are you? And it's Jalaj Aura here again, back with another video from BHM at GCSE Chem. And today we're doing C1.8, which is the last section of chapter 1, which is on electronic structures. So this is the book I'm using, the GCSE Chemistry AQA Caboodle Revision Guide. As I said, we're doing electronic structures, which is C1.8 of the book. And then we'll be, after this chapter, we would have finished chapter 1. And just one thing, after this, on the next page, there are some summary questions. This is if you have the book. I would recommend you get the revision guide, actually. It's really, really useful, especially for, nearer the time in exams. So after this, there's obviously there's summary questions after today's section on the next page, which you can try out. Just to test, if you really understand chapter 1 very well, or you need to go over a few things. So that'll be a good thing to do, I guess. So this is C1.8. I have some paper today because I will be drawing some diagrams because it's on electron structures. So we're going to start with this today. So let's start the lesson. So electrons are arranged around the nucleus in shells. Now each shell represents a different energy level. So electrons are arranged around the nucleus in shells, and each shell represents a different energy level. So basically, electrons they orbit, they go around the nucleus. They're not inside the nucleus, because inside the nucleus you obviously have protons and neutrons, but around the nucleus you have electrons which are in shells, and each shell represents a different energy level. Then we look at this and it says electrons occupy the lowest available energy levels or shells or the shells that are closest to the nucleus. So electrons, as they occupy the lowest energy levels, or which are the shells that are closest to the nucleus. The first and the lowest energy level or shell can hold up to 2 electrons. The second energy level can hold up to 8 electrons. So in the first shell, you have a maximum of 2 electrons, whereas in the second shell, you have a maximum of 8 electrons. So you can't have more than 2 electrons in the first shell, and you can't have more than 8 electrons in the second shell. Now you can show arrangement of electrons in an atom by drawing diagrams or writing the numbers of electrons in each energy level. After 8 electrons occupy the third shell, the fourth shell starts to fill. So basically, after 8 electrons occupy the third shell, the fourth shell will begin to fill. So it's like 2, 8, 8, and then after that, the fourth shell will begin to fill. So that's how it works. Now, here is a diagram. Here's a diagrammatic way of representing the electronic structure, of sodium. So you have sodium Na in the middle, and then you have 2 electrons in the first shell. 1, 2. And 8 in the next shell, and then 1 in the outermost shell. Because obviously sodium has an atomic number of 11, which means it has 11 protons, which also means that it has 11 electrons, because it's a neutral atom. So obviously this is a simple way of representing the arrangement of electrons in the energy levels or shells of a sodium atom. So it's a very simple way, a very simplified way to actually represent it. Now the electronic structure shows the number of electrons in each energy level. So that's what it shows, number of electrons in each energy level or shell. You start recording the number of electrons in the lowest energy level. For example, sodium has 11 electrons, so sodium's electronic structure is 281. So 2,8,1. So that's the way you can represent it without using a diagram. That's just writing 2,8,1, which means 2 electrons in the first shell, 8 electrons in the second shell, and then the remaining 1 electron in the third shell. Because obviously the second shell can only have 8 electrons, so that 1 electron will go in the third shell. So now we've read that. So now we have a question. Aluminium has 13 electrons. Draw a diagram to show the arrangement of electrons in aluminium. So basically, I'll do this on paper step by step. So first off, when it's asked to draw what I would do is I would basically first write the element symbol. So aluminium, here you can see Al here. Then, obviously, for aluminium, there's going to be 2 electrons in the first shell because we need to fill 13 electrons. So because it has 13 electrons, we need to put 13 electrons basically, but there can only be 2 in the first shell. And by convention, when we're putting the 2 electrons in the first shell, we always pretty much put it up and then down. We don't put it like up and here. We don't put it up and here. We put it up and down, like opposite. And that's the convention. I'm pretty sure you won't lose marks if you did it, up and here or up and there. But as a convention, you put one up, one down. That's how you do it. Then the second shell holds up to a maximum of 8 electrons. Now, I've drawn the second shell here. Now, look carefully at how I will fill this. 1, 2, 3, 4. So, hopefully, you can see that I'm going here first. Here, 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 here. So I'm not going 1 and then 2 there as well. I'm first filling it up 1 here, 1 here, 1 here, 1 here. Then after that, because that's 4 electrons, I will start to double up. Because I need to have 8 electrons. But that's the conventional way of kind of doing it. And it's always you go clockwise when you're filling. So you can see then I added another 4, just going around. Now, how many electrons are left? Well, 2 plus 8 is 10. 13 minus 10 is 3. So there are 3. Sorry about the noise if you can hear any noise. But there's 3 electrons left, which will basically go in the third shell, which will basically be 1, 2, 3. So again, filling clockwise, it's 1, then it's 2, then it's 3. So hopefully you can see now that that's the kind of drawing for the electronic structure of aluminium, which has an atomic number 13, so it has 13 protons and 13 electrons. So we've drawn it. By the way, if they ask the electronic structure without drawing the diagram, then it will simply be 2, 8, 3. Now the second question here is silicon has 14 electrons. What is the electronic structure of silicon? Well, the electronic structure, they haven't asked to draw it, so you can simply just write 2, 8, 4. 2 electrons in the first shell, 8 electrons in the second shell, and then 4 electrons, which are the number of electrons that remain, will be in the third shell. So because 2 plus 8 plus 4 is 14, obviously. So now we're moving on to the fact that elements in the same group of the periodic table have the same number of electrons in their highest energy level or shell. So these electrons are called the outer electrons because they are in the outermost shell. So elements in the same group of the periodic table have the same number of electrons in their outer shell or in the highest energy level. And these electrons are called the outer electrons or valence electrons because they are in the outermost shell. For example, all group 1 elements have 1 electron in their highest energy level or outer shell. Now that's a rule that actually works, for kind of the groups here. That if you have an element in group 1, it means you have elements in group 1 have 1 electron in their outer shell. Elements in group 2 have 2 electrons in their outer shell. Elements in group 3 have 3 electrons in their outer shell. So it's quite simple. And so how many electrons are in the highest energy level of group 2 elements? So in the highest energy level of group 2 elements, this is a question, by the way, the answer is 2 electrons in the highest energy level for group 2 elements. So basically the number of electrons in the highest energy level or the kind of in the outer shell equals the group number. So that's a rule to learn. It's quite basic, but because all elements in the same group have the same number of electrons in their outer shell, they all react chemically in the same way. So because all group 1 elements have 1 electron in their outer shell, it means that they all react in the same way, like chemically. That's why they have the same chemical properties. The elements in group 0 now of the periodic table are called noble gases. Now these are very unreactive And the reason why they're unreactive is because their atoms have a very stable arrangement of electrons. Noble gases have 8 electrons in their outer shell, except for helium, which only has 2 electrons in its outer shell. So what does that mean? So obviously group 0 elements, they're also known as group 8 elements, by the way. They're called noble gases. They're very unreactive because they have stable electronic configurations. They're all of their shells are filled. So for example, helium has 2 electrons. Both of the electrons will go in the first shell, and you can see the first shell is full. Neon is another example. Neon has 10 electrons, so it would have 2 electrons in the first shell and 8 electrons in the second shell. And again, you can see the second shell is like completely filled up. Like all the 8 electrons go in with no more room for any electrons. So that makes noble gases very, very stable. And all the noble gases, apart from helium, have 8 electrons in their outer shell, because helium only has 2 electrons in its outer shell. So that's why it only has 2 electrons in the outer shell. But all the other noble gases, they have 8 electrons in their outer shell. And because all the electrons basically completely fill up the shells, that's why it makes them very stable and very unreactive elements. And again, the fact that if we call noble gases, they're called group 0, but if we call them group 8 as well, because they're also known as group 8, remember they also have 8 electrons in their outer shell. So again, that rule comes again, obviously apart from helium, that the group number corresponds to the number of electrons in the outer shell, or the outer energy level, or the valence shell. So here's a study tip. First, synoptic link. So for more information on the reaction of elements and their electronic structures, For more information on the reaction of elements and their electronic structures, see chapter C2. So C2, we're coming on to that tomorrow. But yeah, also study tip here. Make a flowchart to describe how you would draw the electronic structure of the atoms for all the first 20 elements when given their atomic number or their position in the periodic table, which tells you the number of electrons. So basically, this is a very good tip, I think, actually. Like I said in the atoms video, for the first lesson I made, C1.1 atoms, I said to remember the chemical symbols of the first 20 elements. I'd also, recommend, I think you do need to actually know, at least for the first 20 elements, their electron configurations, both diagrammatically and, non-diagrammatically as well. How do you write it with commas separating them? You need to know that. And so the keywords, so the flowchart is a good idea, actually, and keep revisiting that flowchart. Keep it in a place where you're going to see it every day, maybe on your wall or something, stick it up on your wall or whatever. But so that you can consistently see it, and then these electron structures will eventually, electronic structures, you'll be able to do them, and it'll be very good for the exam because you can pick up easy marks from there, from these things. So keywords here are shells. Keywords for this section are shells, electronic structure, and noble gases. So they're very important words. And so now we're going on to the key points. By the way, if you're following the student book, it's pages 18 to 19. I'm really sorry, I don't know why I don't say this before. I should say these things before, but basically, if you're following the student book, the big book, it's pages 18 to 19. So the electrons, so now we're moving on to the key points just before we end the video. The electrons in an atom are arranged in energy levels or shells. The lowest energy, so the electrons in an atom are arranged in energy levels or shells. We know that electrons are arranged in energy levels or shells. That's easy. And they go around the nucleus. The lowest energy level, which is the first shell, can hold up to a maximum of 2 electrons. And the next energy level, which is the second shell, can hold up to a maximum of 8 electrons. We know that. After 8 electrons occupy the third shell, the fourth shell starts to fill. So you fill 8 electrons in the third shell, and then after that, if you have more electrons to fill, that would go into the fourth shell then. And the number of electrons in the outermost shell of an element, the number of electrons in the outermost shell of an element's atoms determine the way in which the element reacts. So basically, the number of electrons in the outer shell for a specific element determines its chemical reactivity. And remember, elements that have the same number of electrons in the outer shell will be in the same group, and therefore they will be reacting, and they'll have similar chemical properties, and they'll react in pretty much the same way. So that's the end of this section, guys. I hope it was useful. So now we've actually finished chapter 1. That's great. We've just done chapter 1, and it's taken 8 days, but hopefully it was really, really helpful for you guys. And tomorrow I'll be starting chapter 2, which is, what is it? It's electronic structures. No, it's not. That's 2.2, sorry. 2.1 is development of the periodic table. So C2.1 is development of the periodic table. So yeah, we're going to get into that tomorrow. Make sure to share, like, and subscribe. I really hope this video was useful. And yes, and by the way, for yesterday's video, if you wondered what I was saying, after I said thank you so much, I was just saying now you can watch the video. I didn't need to say that, but I just did. But I think that's it for me. Make sure to turn the notification bell on so you'll be notified when I'm uploading videos that you can watch. And yeah, as I said, I hope this was useful. Make sure to share, like, and subscribe, and I'll see you tomorrow for the start of chapter 2, C2.1, development of the periodic table. Development of the periodic table. Thank you very much, guys.